we mentioned before that DOE employs statistical approach. Okay, we know that DOE, they employ statistical approach. Like it or not, you need to deal with some statistic when you do your experiment using DOE. Statistical approach, the statistical approach is necessary if you want to draw a meaningful conclusion from data, because statistic after all is basically the study of the data. When you do DOE, you give the data into the program. I mean, if you use DOE software lah, you input the data into the program. So the program will collect, organize, analyze, and interpret for you lah. And also sometimes it can do data presentation in terms of graphical or contour map, 3D contour, and so on lah. So when a problem involve a data that are subject to experimental error, okay, because we see before, when you do this, when you perform any experiment, you have response, and then you have the factors, and then you have this noise. So the noise somehow we try to confuse the relationship between factors and the response. So because you have this, you have what we call experimental error. Okay. So you have so the data is not clean. We can say the data. So when you do this experiment, data normally subject to experimental error lah, because of noise, or maybe even if not noise, maybe because you are by mistake you do this experiment, and that experiment not the same way, and then it will cause the variation in the data. In the DOE, you often heard the term ANOVA. ANOVA stands analysis of variance. Analysis of variance, and variance come from the variation of the data against the mean lah. So because of you have variation, when, as I said before, when you perform 10 experiment in a row, it's not necessarily you get the same result, the same 10 experiment, same result again and again, exact result again and again. You will have some variation. So this variation need to sort of like you need to somehow you need to to deal with. So statistical method are the only objective approach to analysis. If you have this noise, okay, if you have this noise here and there, the statistical method give the objective. So the statistics somehow it give the objectivity lah, objectivity to the data lah, data interpretation and so on. Okay. When you have some objectivity, okay, when you have this objectivity in result, then you can do prediction and so on. Okay, you can do prediction. So that's one of the reason why DOE is synonym with the with the statistic. But you must realize something about statistic. Statistic is not an exact science. So that's important. Statistic is not exact science. You cannot prove anything with statistic. You cannot prove anything with statistic. This is a problem with statistic. It's like the case of the the swan before. Where is the thing? Let me go. Is there any swan? Yeah, this one. The one before we talking about the swan. If you see 1,000 of white swan, it does not prove that every swan is white. You found 1,000 white swan. It doesn't prove that swan is always right. If somebody found one black swan, then your data will be compromised lah. So So statistical analysis is basically based on confidence. That's why you have this what we call the percentage here, the probability, the confidence, the how much confidence, statistical power. We learned statistical power before. So the statistical analysis is basically depend on, where is the thing? This one. Okay, cannot prove ni. So statistic only what we call rely on the confidence. Okay, confidence rely on confidence rather than certainty. So that's one thing about statistic lah. So in other words, the DOE, when you use a DOE, this statistical method in DOE cannot prove that your factors has particular effects. Okay, I repeat, if you use DOE, you have this thing, you have what we call this, let me take this thing, Control C, and then I put here, bottom, Control V, and then I put here. So when you do statistical analysis using DOE, you cannot prove this factor, this factor has particular effect. It just give you sort of like reliability, or what we call, it just provide a guideline lah for reliability and validity of the result. It cannot prove, like the case of the swan before lah. It cannot prove. It just give you the confidence, the validity. Okay. So, for example, let's say what we call, let's say how let's say this previously we talked about the fungus. We grow the fungus that can eat the plastic. Okay, so you see that you at the end, let's say at the end of the day, you see that A sort of like A or B, let's say A and B is give the highest effect in plastic degradation. What statistic does is just sort of like what we call, give some confidence to this thing, to this causation. It doesn't necessarily prove that A always good for this thing, B always good for this thing, because if let's say there are some other person try to disprove, then and success to disprove, then your experiment is become statistically insignificant lah. So the statistic just give what we call just add the reliability to the data. Okay. So as I said, the primary advantage of statistic is to add some objectivity in the decision making process. And if you combine this statistic with a good engineering process knowledge and common sense, then you normally it lead to sound conclusion lah. Okay, so let's put here. Okay, let's recap a little bit. Okay, so what statistics do for DOE is what we call when you perform DOE, you want to to confidently say that such and such factor or noise or interaction are significant or not. So that's basically what the purpose of doing DOE lah. You just want to say this factor, this noise, or this this interaction is significant or not. That's it. It's not like you can say that this factor always and 100% sure will cause this. Okay. So to make this confident, so you want to add confidence. Let me put here to add confidence. What we call confidence. To say in terms to say what, to add confidence so that you can say is this certain factor or certain noise or certain interaction what we call is significant or not. Is significant, either it's significant or not significant. Significant. But in order to be confident in anything, you need evidence. In order to get this confidence, you need to have evidence. You need to bring in evidence. You need to bring in evidence. Evidence. Okay, to be confident to say that this is significant, this is not significant, you need to bring evidence. So this is basically where the statistic come. Okay, statistic come. Okay, so you see things like p-value, you see something like ANOVA, you see something like a t-test, you see something like f-value. So all this is basically evidence lah. Evidence that is used by the statistical analysis to show that, okay, this caused this. We are confident this is causing this. So that's the idea lah. So based on this evidence, what happened is that the DOE will predict, we do the prediction lah. Normally they come up with the what we call model equation. Model equation, because you already have evidence, so now you are confident, so DOE will give you model equations. Okay, model equation. So example, the regression line, and so on lah. And the contour map. So they give you sort of like a prediction lah, and then the optimization or confirmation and so on. So those model, what we call, will predict what will happen if you change such and such factor to a certain amount. So for example, let's say this model, they predict, predict your yield improve 50%, and then you test the model, because you need to confirm your model. You test your model and you find that true enough that this model will give you 50% improvement in the yield, then you get some improvement lah. So that's basically the DOE. I mean, why DOE use statistic to add the confidence, to make you confidence that this is significant or not significant. In order to be confident here, you need to bring the evidence, and statistic bring the evidence by means of p-value, t-test, f-value, ANOVA, and many more lah. So this is just part of this thing, part of the analysis lah. And then once there are evidence, the software or whatever statistical software can sort of like combine all this evidence in such a way you can create the model equation. And this model equation, they predict what will happen if you change this factor this much, change this factor this much, and so on. And they give you some run. So if you test that run and you get what is predicted, let's say the prediction is 50% improvement, and you get 50% improvement, then voila, you get what you want. You get the improvement. So this is this make the experiment more objective rather than judgmental. If not, if there are no statistic, you just think that, okay, this caused this, but what's then? What's next? And so on. And if people ask, what is the evidence that you say this and that? There are not much evidence. So if you have this statistic, you have this evidence lah. So that is why you need the statistic lah. So now let's discuss about the statistic in general. Just the idea of statistics. So I give you in the chat, I provide this some related statistic to DOE. As statistic, you need to know something about mean, variance, standard deviation, standard error, confidence interval, z-score, whatever this thing lah. So I will not touch everything, but before I touch this, this is basically the how you calculate, okay, how you calculate the statistic. But then before you calculate, you need to know what you want to do actually, what you want to achieve actually. I mean, calculation is one thing, but you calculate what? Calculate for what? Okay, so for that, we want to go a little bit back and learn about the basic of statistical analysis. Okay, let's go here. Let's go the new page. So we talk, maybe with this statistic that relate to analysis. Okay, so that's what we want to learn. So we will start with discussion the big picture first. So we will start with the discussion about the population, sample, and hypothesis testing. This may be quite dry, but bear with me. So we will talk about the population here. Population, sample, and hypothesis. Hypothesis testing. Testing. Because this is the very base of the statistic. Okay. The reason why people do statistics is because this. Okay, so let's talk about the population first. Okay, population is the entire thing. Population here. So the population is the entire thing. It can be you may know the what we call the you may know the amount, size, or we call it sample size. Size is known, or you may not know the size. Size is unknown. For example, size is known. For example, let's say in your house, you have the cat. In the house, you have a cat. Cat. So you know how much cat in your house. So the house is your house is becoming what we call the constraint of the population. So let's say you have 5 cat. So the population of cat in your house is 5. But if let's say you want to find how much cat in the world, then you might not be able to find it. So the size can be can be known, can be unknown. So if let's say the population constraint is small, let's say in your house, then you can know the size. Population can also, the size also can be unknown, like this case, the cat in the world cat in the world, like that. So when you have this population, these two things, when you deal with these two things, we call it parameter. Okay. So that is population. The second thing is, let me put here. So this is population. The second thing, we call it as sample. Okay, sample. Sample is basically is a part of population It's part of population. And normally you know the size. Normally the size is known Size is known. Okay, when you deal with this what we call the sample, you are basically doing statistic. So when you talk about statistic, this is what actually it is statistic. So when you do sampling, you are doing statistic. Okay, often you know whether you deal with the parameter and statistic when you see the statement. For example, let's say I give the statement A. Okay, 50% of your family cat is light whiskers. I mean cat food And B, 50% of cat like whiskers. Okay, there are two statements here. So basically the first statement, the statement A is basically the what we call the population. This thing, the statement relate to the population. So this is population because you know how much cat in your house. You have this constrained population, even though there are maybe 5 cat only, but because they are what we call the constraint here, your family cat, meaning that in your family house So you have constraint on the population, so you can say this population. This thing, the B1 is the sample. This is a statistic. Because in order to know this, in order for B to be true, you need to test all the cat in the world because it's generic. So this is type of the statistic. You for sure people don't what we call test the entire cat in the world. They just they just test only few cat, maybe 50 cats and so on. So the conclusion here, the conclusion that you get from here, the conclusion is statistical. Okay, so for A is exact for B is what we call ni. So most of the time your experiment whatever is like this. You're dealing with statistic because it's unlikely you test the entire population For example, let's say you are doing survey, one of the type of experiment, especially non-science, they're doing survey. So you don't interview all the individual in the country to know whether one politician is good or bad. You just ask few of them. You just ask few of your friend whether this politician is good or bad. For example, let's this is so normally, so one is a politician, and the second thing, let's say you are quality engineer in one factory and you are making a screw. Let's say you are making a screw. You're making a screw. You don't test every screw that is coming out from the production line. You test only a few screw. Okay, so the idea of sampling, so this you test only a few, is, we call it sampling. So the idea of sampling is basically to what we call to the idea is that you want your sample to represent the population. So the aim is sampling. The aim is to represent the population lah. Represent the population as close as possible lah. For example, you let's say you ask 10 of your friend about this particular politician. You want to make sure when you do that, you hope that the conclusion that you get, whether it's good or bad, is what we call is similar as if you ask the entire population of the country or so on. Similar with this thing, the screw. Let's say what we call you measure 100 screws. Let's say you measure 100 screws for this, and then this what we call this 100 screws measurement. For example, the length for these screws, maybe let's say 10 cm. So you measure 100, but your company produce like 1,000. So you want, when you do the sampling, you want this 10 cm also represent for others. You want to make sure that you sort of like hope that the rest in the one that you ever produce is also 10 centimeter in length. So that's the idea of sampling. You do this, you check from the part of the population, but you want whatever you test to be representative of that lah. So that's the reason why you don't use statistic to prove. Okay, because let's say you have n population, you don't know what is population. Let's say we put n. In order to know exactly, you need to test all these things. In order to know exactly the result, you need to test every single n population. Let's say in the country, you need, let's say you want to about politician just now, you want to know whether it's good or bad, you need to ask the entire individual in the country in order to be sure. But if you take sample, you are not sure. You are sort of like you hope that it will represent the population lah, as if it will same conclusion you get even if you ask many people, the whole population. So that's why you don't use statistic to prove your finding. You basically use statistic. So use statistic either to what we call to prove or disprove the hypothesis. So this is what the purpose of statistic lah. You don't, let me put here this color. So you don't use statistic to prove finding, to prove finding. Okay, you don't use statistic to prove finding, but you use statistic to prove or disprove the hypothesis. Now come with the hypothesis. What is the hypothesis? Okay, this maybe is quite abstract for you, but actually when you do DOE, this is basically what when you perform the statistical analysis in DOE, that is basically what they do. They want to either prove or disprove the hypothesis, the hypothesis that you put lah. For example, let's say I put the hypothesis here. Hypothesis and the hypothesis. What is hypothesis? Normally, whenever you read any statistical book, you heard about the null hypothesis and so on, right? So null hypothesis is basically this. So H naught is basically null hypothesis. hypothesis. Okay, and then you have another one, HA, which is alternative hypothesis. Okay, null hypothesis is basically the status quo, meaning that there are no effect. Okay, you remember we learned about effect or no effect, high effect, low effect before. So null hypothesis is said that there are no effect. Alternative hypothesis mean there are effect. So I give you an example. Let's say the null hypothesis is that you want to test about sugar and diabetes. So the null hypothesis, let's say, is sugar does not cause diabetes. So this is the null diabetes, whatever lah. And then you have alternative hypothesis is sugar cause diabetes. So when you do experiment, you are basically either you want to prove or disprove these two things. You don't say sugar you don't want to prove the thing. You just sort of like you want to disprove the hypothesis. If let's say in this case, for example, let's say you found after the end of the experiment, you found that sugar cause diabetes, then basically what not cause, I mean, if let's say this is the hypothesis only, if let's say when you perform experiment you found that sugar correlate with the diabetes, then what you did is basically you are rejecting the null hypothesis. For example, during experiment you found the sugar, they are associated with the diabetes. So basically what you do is that you are rejecting this null hypothesis. Okay, so in other words, when you reject this thing, what does it mean is that the statement sugar cause diabetes is basically is the most likely outcome lah. But you never be sure because maybe because you are testing the sample. When you do the experiment, when you want to do this type of experiment, sugar and diabetes, you not asking all the population, you just test a few % only. So there are case, maybe some person somewhere, maybe in Antarctica, that they can consume 1 kilogram of sugar per day for 10 years, but still not having any diabetes outbreak. Then then you can say that your alternative hypothesis will be rejected lah. So for example, let's say someone that can consume 1 kilogram of sugar every day, and then no diabetes. So what happened is basically you are proving the null hypothesis lah. You prove the null hypothesis. So this you reject. Okay, so if let's say I put this, if somehow you find some person like that, okay, so that is basically ni lah. So you know, that's about the hypothesis. So all this thing, whatever you do in DOE is based on your hypothesis. Okay, later we see how this hypothesis relate with the p-value and so on. Okay, so now how you add the objectivity to the DOE? How you add objectivity to it? So how DOE add objectivity to your finding? Okay, so first they use a statistical significance lah. We have encountered that before. They use what we call statistical significance. So you can say it's a way to tell you if your test result is solid. Okay, statistical significance is the way to test whether your result is valid or not. So statistic, as I said before, is not an exact science. Okay, you can think statistic as like a finely tuned guesswork. Okay, so you can think statistic here as a finely tuned guesswork. Okay, guesswork. because it's a guess, you need to know how close is your guess is. Okay, you cannot just even though it's finely tuned guesswork, but you need to know how close your guess with the reality lah. That's where the significance coming in. That's why this part coming in order to make sure whatever you guess have some level of significant, confidence is it. Okay, so normally what you do if you want to what we call to find the statistical significance is basically first you are deciding the risk factor lah. You decide the error rate lah. Decide the error rate, or in this term jargon they call it alpha level, and then you conduct experiment, and then you calculate the statistic, conduct the analysis lah, analysis, statistical analysis on the data. This is where you sort of like piece your information, okay, like things like mean, mode, median, and so on, variance and whatsoever. And then you conduct the statistic, you compare your statistic, compare statistic of your analysis based on what you compare. Normally you compare with the Z table and T table. I will show you before later. So basically this table it will show you whether your data lies in the region of significant or not, because at the beginning you sort of like you decide the error rate here. So this basically same like a power thing lah. So when you know how much you want your experiment statistical power is, then you sort of like have sort of like confident. You want to put some confident, how much percent confident you want to put in your result. So that's where this decide the error rate and so on. You conduct experiment, you have the data, you conduct analysis, and then after you during the conduct analysis, what we do is that you compare the statistic whatever you get based on the Z table and T table, and this is where you find things like what we call p-value and so on. Okay, so this table is basically tell you the region of confidence. Okay, whether your data lies in the regions of confidence or not confidence. If the data is outside the regions of significance, then there are no interaction lah, no interaction or no effect lah. Okay, so now we talk about statistical significance. We talk a little bit also about what we call confidence level lah. So this they are relate with the confidence level. Let me put here confidence level. Let me put here confidence level, okay, or CI. Okay, so this statistical significance, the one that you see here, is basically relate to the confidence interval. Okay, if you are confident that your sample measurement would match the population measurement 95% of the time, then you say that you have 90% confidence level lah. Confidence level and not CL, this CL, not CI. Confidence level CL lah. So this confidence level is where you find something like 95% or typically people use this 95% confidence level lah. This is common lah. So you are the one who decide what level of confidence you want your result will be. Okay, so normally if your confidence level is 65, so your what we call the error rate, this alpha level. So if your confidence level is 65, so your alpha level will become 100% minus 65%, you got 5%. So this 5% we call it as a alpha level lah. alpha level, meaning that what is the risk that you willing to take. Okay, the risk that is where the what we call your result is maybe not because of the relationship between the factors and the response. Okay, so in this normally when you deal with the statistical software, they don't give you in this 5%, they give you in like 0.05 like that. They put it in decimal. Okay, so this decimal have something to do with what we call the p-value. Okay, so let's talk about the p-value a little bit. Okay, so let me put here p-value. Okay, so you see this again and again in DOE software later on. Okay, so you get p-value. This I cannot see. It's okay. This is 0.05. Let me put here lah. Let me put here. Wait, so that you can see here. So let me take here. And I put here. Okay. So that's okay. Then I bring it myself here. Okay. So now about p-value. So now we learn what? We learn there are something called alpha level, something called confidence level. Okay. We have alpha level and confidence level. Both of these they connect with each other. Okay. So it's other way around lah. It's just confidence level and alpha is relate with each other. So if let's say the p-value is lower than what we call, if p lower than the alpha, so we can say it is statistically significant. Statistically significant lah. Significant. Okay. And then if the p is above the alpha, then it will be what we call statistically not significant lah. So the alpha here, this part here, the alpha here is decided by the people. I mean, let me put here, is depend on the field. Commonly, the alpha level that people normally put is 0.05 or 5% lah. 5%. What does it mean? This 5%? 5% of the probability to incorrectly reject null. What does it mean here? Is 5% probability to incorrectly reject null hypothesis. Because remember, at the end, after all, what you do in statistics is basically either to prove the null hypothesis or reject the null hypothesis. Null hypothesis is a status quo. For example, in this case, sugar does not cause diabetes. So if you able to reject this, then you sort of like you have this what we call confidence that sugar cause this diabetes. This 5% thing, when you put alpha 5%, it means that 5% probability that rejection is incorrect. I mean, to incorrectly reject as null lah, due to certain noise and whatsoever. So certain some of the what we call some field they use alpha even stringent, maybe 0.01, meaning that 1% probability, mean that they are more strict in that. So this 1%, and sometimes people use less strict, 0.10 like that. So this is 10%, this is 1%. So depending on the field, but most often you will see this thing lah, 0.05 lah. That is what's commonly you see lah, the p-value. So but basically what is this percentage and so on? All of this is actually based on the normal distribution. Later I will talk about normal distribution. Maybe the discussion now is quite haywire here and there, but later on it will fit together lah. So this thing, the P and what all this thing is based on the normal distribution. Normal distribution is when you see the graph something like this. You see graph like this. Most of you have seen this thing, this graph. This is what we call the normal curve. Okay, normal curve. We will talk about normal curve later. But this alpha, I want to show where is this alpha and so on. So if let's say I put the what we call this thing, this line here, okay, this line. So let's say this is 1 minus alpha. 1 minus alpha, meaning that this is alpha lah. So this is 1 minus alpha. 1 minus alpha. So our alpha is 5%. So meaning that the area here is 5%. 5%. The area here is basically 95 lah. 95%. 95%. So normally here is we call it critical value lah. Critical value. Critical value. Okay. So if let's say in your test here, let's say here, in your sugar test, where is sugar test? This sugar test, let's say this sugar test, you found that your alpha is 0.03. Let's say in the sugar, let's say, example, let's say you got P equal to 0.03. So this what statistic tell you, because they give you numbers lah. So this P equal to 0.03 is basically less than P is less than 0.05 lah. So this is basically your what we call your level that you put. Okay, so meaning that your thing, whatever effect interaction that you get lies here, somehow lies here, because it's less than 5%. So that's 5%. It lies somehow somewhere here lah, somewhere here. So because it is far from the normal, mean that it's like sort of like outliers, so we can say that this thing have some effect, they cause some effect. Remember, the null hypothesis assume that there are no effects. Null hypothesis mean there are no effects. You see, sugar does not cause diabetes. So null hypothesis, typically they say that no effects. Alternative hypothesis, basically they say there are effects. The effect we learned before, there are significant effect, medium effect, low effect, and so on. So that's the effect. So they want to test this thing. So when you see the word P minus less than 0.05, meaning that they find whatever the value, the P, they find in this region lah. Okay, we need to talk about the normal distribution later on lah. So P value, so what you see here, the P value is basically one of the way only to testing, to give the objectivity to what we call, to the statistic during the statistical analysis. But you also have something like t-test, like ANOVA, and so on, F value, and so on. Okay, so combined together, they sort of like team up to give the what we call your finding some objectivity. So that's the idea lah. So when you have this, so you add this objectivity lah, objectivity. So when you have some objectivity, then it's very what we call it's very hard for others to argue lah, provided you know what you do everything correctly lah, from design, experiment, analysis, and confirmation. So if you do everything correctly and you reach this level of result, then people is hard to argue, because you bring the evidence now. You bring the evidence, okay, P is this, and so on. But if you make a mistake, for example, selecting the incorrect design, then the statistical software still give you the value, but it's misleading. So be careful. The most important, that's why we start with the understanding how to make a good experiment and so on. Because it's very important for you to start right. Because after you start the process, then there are no way back. You start the process, you already consume all the budget and so on, and then you get the result. The statistical software will give you the result, but whether that result correct or not is other matters lah. Okay, so you add the objectivity. So this what we call, you make, so in other words, you don't make judgment based on what you think. You make judgment based on what we call statistical evidence that is given. So this is example of statistical evidence lah, the numbers and so on, the R squared, whatever, and so on lah. So that's how the statistic come into DOE. The idea of the statistic is to, the main idea for statistic in DOE is to either what we call this thing, reject or approve, reject or accept the null hypothesis. And this Normally a null hypothesis mean no effects. Remember the main, what we call the main purpose of experiment, for example these factors, right? Factors and the response. The main purpose of you doing experiment is to vary the factors to see is there any cause, any relationship with the, what we call, is there any relationship between these two. So status quo said when H null, the null hypothesis H naught here, it said that there are no effect between factor and response. So that's what does it mean. Null hypothesis, they said there are no correlation, there are no causation between factor and response. So you do the experiment. So basically, when you put things, data in the statistical analysis software, whatever, what they did is that they want to see, they want to accept this null hypothesis or they want to reject this null hypothesis and so on. So you can see here, statistic add objectivity to the your result lah, your result. Because remember, after all, statistic is not the exact science. You just want to be confident on that thing. Because even if you don't use DOE, you do the experiment, just do the experiment, trial and error, you still get result, right? But that, when people ask the evidence, is it really the way, really the result? Will you are you not testing other factors and so on? So you cannot answer. So when you do DOE, you already design your experiment, and then you have the data, you analyze the data, you have the, what we call, the result in terms of the statistical analysis, and then you can say by confidence, okay, this I believe it will cause this thing because of this and this, because this factor is significant and so on. So that is basically the idea of the why you see the statistic. I mean, something you need to know about statistic, population, sample, hypothesis testing, and all these things. All start with this. All start with the null hypothesis, whether you want to reject or not.